Okay, let's look at a sampling question. Our first task is to estimate the probability of plus C given minus A minus B minus D using rejection sampling. These samples have been generated from prior sampling, meaning that the rejection stage hasn't happened. Okay, so we're asked to reject the samples that rejection sampling would reject. That means the ones that are not consistent with minus A minus B minus D. Okay, we just check all 6 of them and see which ones have minus A minus B minus D. Not the first one, not the second one, yes for the third one, not for the fourth one, not for the fifth one, and yes for the sixth one. Now based on these samples, estimate the probability of plus C given minus A minus B minus D. Well, we have minus C here and plus C here, so it's 1/2. Using these samples here, which were generated using likelihood weighting, estimate the probability of plus C given minus A minus B minus D, or state why it cannot be computed. In likelihood weighting, we step through the variables one at a time. If they are in the evidence, we force them to take on the evidence values. If they're not in the evidence, we sample them from their conditional distribution. So let's start with the first one. When we get to A, we force it, because it's part of the evidence, to be minus A. So if we look up here with the probabilities of minus A, it's 4/5, so that results in a reweighting by 4/5. When we get to B, B is also in the evidence, we force it to be negative B, that's 2/3 in our reweighting. When we get to C, that's not in the evidence, it's up front. So we sample C, so no need for reweighting or reweighting by just 1. And when we get to D, we force it to be minus D because it's in the evidence, and C was minus C, so it's this entry over here, and we reweight by 3/4. Overall, this gives us the 3's cancel, the 4's cancel. This gives us 2/5 as the weight of this sample. For the second sample, when we get to A, we force it to be minus A because it's part of the evidence. That's a reweighting of 4/5. When we get to B, we force it to be minus B because it's sitting in the evidence. That's a reweighting of 2/3. When we get to C, we sample it, so no need to reweight. When we get to D, we force it to be minus D because it's in the evidence. Minus D given plus C, that's this entry over here. So that's a reweighting by 1/2. Altogether, this gives us a reweighting by 4/15. Then the third sample is identical to the second sample, so the weight here is also 4/15. Now to get this probability of plus C given minus A minus B minus D, so we look at the samples that have plus C, which are the 4/15 and 4/15. So we get 4/15 plus 4/15, the sum of the weights of the sample that satisfied everything, and then we divide by the sum of the weights of all the samples, which is 2/5 plus 4/15 plus 4/15. Okay, let's take a look at D, Gibbs sampling. We need to circle any sequence that could have been generated by Gibbs sampling. What does Gibbs sampling do? It starts with an instantiation of all variables. If there is evidence given, then that instantiation is consistent with the evidence. Here we're not given any evidence, so nothing to worry about there. And then once we've instantiated all the variables, we resample one variable at a time, conditioning on all the other variables' values. Okay, so we start with some instantiation. Then we would resample one variable. In this case, we end up with the same instantiation. That's possible. You resample one variable and you end up sampling the value it already had. And then in the next step, we resample again one variable. In this case, just C changed. So that's possible. This is consistent with the Gibbs sampling procedure. For sequence 2 here, we start with an instantiation. Then we resample one variable. Only one variable changed, so that's consistent with what might happen in Gibbs sampling. Then in step 3, we resample again one variable, but we see that 2 variables changed. So this is not consistent with the Gibbs sampling procedure. Here we start with a sequence with an instantiation minus a minus b minus c plus d. We resample one variable, we get one change. That's reasonable for Gibbs sampling. Then in the next step here, we again get one variable that changes, so that's consistent with Gibbs sampling. And so this third one could also be generated by Gibbs sampling.